Second part, electromagnetic spectrum. By the end of this presentation, you should be able to explain what happens when electrons get excited, calculate frequency, wavelength, and velocity using the speed of light, and calculate energy using Planck's constant and the speed of light. So what is light? Light is a kind of electromagnetic radiation, like radio waves or microwaves. Electromagnetic radiation includes many types, like I said, gamma rays, X-rays, radio waves, microwaves. And we use the speed of light for our velocity. So usually it's 2.99 times 10 to the 8th. We can also use 3. We can just round it up to 3 times 10 to the 8th meters per second, and is abbreviated with a little lowercase c. Frequency. So different frequencies of light are different colors. And there's a wide variety of frequencies, and the whole thing's called a spectrum. And this is the equation for frequency. You have your speed or your velocity equals your frequency times your wavelength. And for us, for chemistry, our speed or our velocity will always be c. So you'll always use the speed of light for your velocity. So here's the electromagnetic spectrum. And down here, low energy, low frequency, and a long wavelength, you have radio waves. And as you move this way, you get higher energy, higher frequency, and shorter wavelength. So here you've got your gamma rays, and those are really high energy, as you can remember from nuclear. This is what will get you the mutations. And in the middle, you have the ones that we can see, the visible light. So this is what we can see. We can't see any of the other ones. These little lines here are sequences of light, and they're called atomic emission spectra, and each element produces its own atomic emission spectrum. They're kind of like fingerprints. They're unique to every atom, and so we can identify atoms or elements by the light that they emit. So light is a form of energy. It can move as a wave, or it can be a particle. And particles of light are called photons, so little packets of energy. So when we write our electron configurations, we're writing the lowest energy. And the energy where you start from, the lowest energy level, is called the ground state. And we can calculate that energy of the ground state by using Planck's constant. So here we have another equation. Energy is E, so this big E is energy. H is Planck's constant, which is given to you here. And it's on your reference sheet, so you don't have to memorize this. And then you have your velocity, or your frequency of radiation. And I sometimes it's E equals HF, and I think this is how it is read on your star reference chart. So we're going to use this one, E equals HF. It's the same thing. The Bohr model of the atom. So Niels Bohr pictured the electrons orbiting the nucleus in like planets around the sun. But he said, no, they're in specific circular paths, and they can jump from one energy level to another. So here, if you look, this is a hydrogen atom with one little electron, and these are all the different shells that it could be in. But it starts here at the very lowest energy level, and then when it gets heat, or however it gets excited, it can jump up into the next energy level. So after it jumps up to the next energy level, and it falls back down because it always really wants to be in its ground state, its lowest energy level, it will emit this light. It'll give the energy back, and we see it as light. Alright, so now y'all are ready to do your flame test lab on Friday to identify different elements. If you need to go back and review this tutorial, please do so.